Before we dive in, a quick note. What you're about to hear is a reworked version of an old Filter Stories episode about water for coffee. The original version that came out like 3 years ago, it's still down in the feed if you want to listen to it. But I decided to rework that episode because it was just too dense. I mean, if you're a scientist, a chemist, you probably love the episode, but frankly, for a lot of peeps who are not scientists, I think it was just too much science. And so what I've done is taken some time to rework that old episode into something that I think is going to be really fun, surprising, and even if you've heard the original, you're going to love this one too. Because I make the case that 500 million years ago was actually when we had the best water for coffee on planet Earth. So a few years ago, before I started making podcasts for a living, I worked as the wholesale director for The Barn, a Berlin-based coffee roaster. And I remember I was on the phone with one of our cafe customers in Oslo because they had a problem. They were like, James, we're hearing in the community that water makes a big difference to the flavor of coffee. But is it worth us spending all this money on a water filtration kit? I don't think we should. Because, in Oslo, the water out of the tap tastes really good. And when it comes to water for coffee, I think a lot of people have this same assumption. If the water tastes good by itself, and then you add high quality coffee, you're going to get an even tastier beverage. And the opposite is true. If the water itself doesn't taste very good, and then you add coffee, then your coffee brew won't taste particularly good. But here's the thing. As far as my taste buds are concerned, that's not true. Because back in 2022, I actually put that assumption to the test. I hopped on a train from Berlin to the offices of BWT, Water and More. They're the sponsor of this episode and they provide water filtration kits to cafes. And I hopped off the train in Wiesbaden, a small city along the Rhine in Western Germany. And at the BWT office, they had stacked a big rectangular table in one of their meeting rooms with cups, bowls and kettles. We were about to taste some water. So this is how the test was going to roll. I would taste 4 different waters by themselves. And then I'd taste those same waters, but this time boiled up and added to coffee. And it would all be anonymized. I didn't know which was which. Okay, so the first water I tasted was literally water out of the office kitchen tap. Local Wiesbaden tap water. That's really good water. That's delicious. And for the record, I would happily pay money for a bottle of that. And then I tried that same Wiesbaden water that had come straight out of the tap, but it had been filtered using one of BWT's Best Max Premium water filtration kits. Yeah, it kind of tastes a bit metallic. There's a kind of a sheeny coatingness to it. It's kind of a bit odd. This filtered water by itself, it didn't taste bad, but it had nothing on Wiesbaden tap water. Now, using the logic of that Oslo cafe, right? Delicious water plus delicious coffee equals even more delicious beverage. The unfiltered, straight out of the tap Wiesbaden water should be the one that tastes the best with coffee. So I ground out some coffee, which, by the way, was a Yogurchef roasted by Nano Cafe here in Berlin. Added the hot water to the ground coffee in bowls. And I tasted regular Wiesbaden tap water plus coffee. Flat. Not very interesting. Not particularly acidic. And this water, which tastes amazing by itself, you add it to coffee, and the coffee tastes kind of lame. And then I tasted the coffee made with the BWT Best Max Premium filtered water, which I didn't initially like because it was sheeny, metallic. But you add that to coffee. Ooh, I like that. I like that one. It was as if I turned the key on a perfume box, and as it opens, you get a waft of jasmine. I like number 3. 3 is great. And so, thinking back to that cafe that I consulted all those years ago, that cafe would have tasted this and they would have realized it doesn't matter what water tastes like by itself. It matters what's in it and how that interacts with the coffee. So it really begs the question, what kind of water makes the best coffee? And I'm going to give you that answer right now. To make great water for coffee, 2 particular things really matter. How much calcium and hydrogen carbonate are in your water. You definitely don't want too much, but you don't want zero either. And now you're probably thinking to yourself, wait, calcium? Hydrogen what now? This is the point. Chemistry is so hard to remember. So, in this episode, what I'm going to do is give you a story that will help you never to forget these two things, calcium and hydrogen carbonate. A story about you. Well, your ancient story. It's the story of Earth itself. Because here's the thing. At one point in the story of Earth, the water you would find underground was the perfect water for coffee. Then you fast forward millions and millions and millions of years to today, and now when I open my tap here in Berlin, what I get is bad water for coffee. Water that makes my coffee taste flat and dull. Water that gunks up our kettles and espresso machines. So this episode is the story of how water came to Earth in the first place, why there was a moment when that water was perfect for making specialty coffee, and then who came along to ruin it. And yes, there is a culprit. There are many culprits, uncountable trillions of them, and they're all lying dead right now under your feet, haunting your coffees from beyond the grave. And their weapon of choice? Hydrogen carbonate and calcium. I'm James Harper, and this is Filter Stories, the untold stories hidden in your cup of coffee. And you're listening to The Science of Coffee, a journey into coffee's hidden microscopic secrets. So, I want a cup of coffee. I go to my kitchen, open the tap, fill up my kettle, boil it, and I brew up a cup of coffee. And it tastes awful. Flat, uninteresting, dull. And my kettle looks awful too. It's all calcified. Where I live, Berlin, Germany, the tap water is just bad water for coffee. It is way too hard. As in, it has way too much stuff dissolved into it, especially hydrogen carbonate and calcium. And I know I'm not alone. Many, many, many people around the world live in cities with very hard tap water too. I saw some estimates that 90% of American homes have hard water. That means the majority of Americans have bad water for coffee coming out of their taps. But like I mentioned, it wasn't always this way. In fact, at one point in the distant past, the water from our taps would have been absolutely perfect for coffee. I mean, we would have had other problems too, like the fact that, coffee plants didn't exist yet, but that's not the point. The point is, something came along to screw up our water. But before we get there, to begin the story, let's answer maybe a more fundamental question. Where did water come from in the first place? Water, of course, being very important for coffee because a cup of coffee is mostly just water. And I want to start this story at the very beginning, before there was even Earth itself. And to help me tell that story, I spoke with a very respected author.
I'm Marcia Bjornerud. I'm professor of geosciences at Lawrence University in Appleton, Wisconsin in the US.
Marcia wrote a book that my dad, when he read it, he honestly wouldn't shut up about it for like the next 5 years, which is Reading the Rocks, the autobiography of Earth.
So let's go way back to before there was an Earth and think about where the elements come from. So all of the elements that make up our solar system and the Earth itself are recycled in some sense. They're from earlier star systems that finally ended their lives in spectacular explosions, and the stuff got remixed and incorporated into new stars and solar systems.
In the distant past, ancient stars burned brightly. And what those stars did was take the hydrogen and helium, the two simple elements that were created during the Big Bang, and fuse them together to create the more complex, heavier elements. Things like calcium, oxygen, iron. And when those stars blew up in spectacular supernovas, these elements were fired out in all directions. And gravity pulled them together into giant clouds of stardust. And one of those clouds of stardust was Earth. Our Earth.
And we think that this actually did happen relatively quickly, geologically speaking, between that supernova precursor star that blew itself up and gave us the guts that became the planets, and the time that the core of the Earth separated was probably only about 30 million years.
But the crazy thing is that when the Earth was really young, like we're talking over 4 billion years ago, just after it came together, Earth is actually a sea world. It was as if you're in the Pacific Ocean, with just water, oceans everywhere, and maybe the occasional volcano popping out, spewing lava into the ocean. So, where did all this water come from?
So that's an interesting thing. We don't even know where all this water came from. Earth's abundant water is really kind of a mystery. So there are two possible sources. It could either be primordial, so that would be water that has been here since the beginning. Or, and these aren't really mutually exclusive, it could be a combination. It could be that much of the water was imported after the planet formed from comets.
So whether we got that water from the space dust or from comets that slammed into Earth later, we don't know. But here we are, we have water. Shall we now taste coffee with this ancient water? So let's imagine. We hop in a time machine with a little backpack full of coffee beans, a grinder, kettle, brewer, and we turn the dial back 4 billion years. And we land with a splash into this ancient ocean. Our time machine capsule bobs up and down the ocean waves. We open the capsule door, take a deep breath in, and suffocate. Because there's no oxygen here. And we're going to die in a couple of minutes if we don't put on an oxygen mask. But luckily, we've packed one of those too. So, oxygen masks on now. We scoop our kettle into this ocean water. We boil it up, grind up our beans, brew our coffee, and take a sip. And wow. This is bad. This is really, really bad. It's super salty. I mean, this is the sea after all. But it's also like super metallic. Oh. And if we even managed to get a whole cup of this coffee down us, we would die. It would kill us. Because this ancient water, it is full of iron. Toxic levels of iron. So the verdict from 4 billion year old water, it makes a god-awful cup of coffee, and it'll probably kill you too. But what happens soon after is that Earth undergoes an incredible transformation that will eventually make water that's amazing for coffee. That is coming up next. So, billions and billions of years ago, stars exploded, and that stardust came together to form Earth. And Earth back then, it was actually a watery planet. There was just so much water on the surface. Quite how it got there, geologists are still hotly debating, but from the point of view of brewing a cup of coffee, the big problem with this 4 billion year old ocean water is that it's full of toxic levels of iron. It also tastes terrible too, but the iron and lack of oxygen in the air are the things that are actually going to kill us. But soon after, something happens that removes these toxic levels of iron in the ocean and puts oxygen into the air. It's a very minor, inconsequential thing. A very strange phenomenon known as life.
So the earliest, probably unambiguous evidence of life is at about 3.5 billion years ago.
So when Earth is still young, 500 million to maybe 1 billion years old, simple organisms start coming to life. The evolutionary biologist Richard Dawkins has a really great book on this called The Selfish Gene that basically argues, look, once certain conditions are met, life is inevitable. And Earth at this time has the right conditions. So life is forming and evolving. Another inevitable thing that's going to happen. Okay, and now I want to fast forward the story a bit. Imagine if this entire time we were actually reading the book of the story of Earth, right? So if I'm holding up this imaginary book of the story of Earth, what I want to do now is fast forward the story, flipping through the pages really fast. And we're going to stop now in the middle of this book, when Earth is slightly more than 2 billion years old. And right in the middle of the story of Earth, evolution brings us this very particular life form called cyanobacteria. To me, it just looks like blue-green algae. But this cyanobacteria, there is so much of it. It creates what scientists call the Great Oxidation Event. This cyanobacteria changes the water and the air. It changes everything. Because they were one of the first ever species to do what plants do today all the time.
Some of the early organisms were photosynthesizers, and that's an amazingly sophisticated thing.
Photosynthesis. And as we know from biology class back in school, a byproduct of photosynthesis is oxygen. So cyanobacteria create a lot of oxygen. And all this oxygen then rusts all that iron swimming around in the ocean. And so the levels of iron in the water go down and down and down and down. The ocean water slowly becomes less toxic. And while that's happening, the air is becoming more breathable because there's now oxygen in the air. So all these changes are pretty great. But things are going to get even better. Because what I want to do now, I'm going to pick up the book of the story of Earth again, and I'm going to flick through this book faster now. Simple organisms evolve into more complex organisms. Entire chunks of land begin to form. We have the phenomenon of plate tectonics. So now we have continents moving all the time, creating mountains. And now I'm going to flick all the way to the final chapters of this book. So we've just seen 7/8 of the book. We only have a final 1/8 left. And this moment here, 550 million years ago, was, I think, the most beautiful point in Earth's history. The Golden Age. Not just the Golden Age for water for coffee, the Golden Age for life on Earth. And let's see it up close for ourselves. So, we're stepping back into the time machine, and I'm turning the dial to 550 million years ago. We step out of the time machine, take a deep breath in. And we can breathe. This is clean, fresh air, full of oxygen. Also, we're on hard land. And okay, look, this bit's kind of boring. It's just rock. Just a lot of rock. But I want to show you what's happening in the water. So we walk down to the shore and look into the water. And in the water, we see algae, underwater ferns, and some little critters scurrying around.
And the first animals were just soft-bodied things, worms and things that didn't have any body armor.
And the reason they don't have any body armor is because they don't need it.
And this sort of seems to be this Edenic time when most of these organisms were just grazing on the seafloor and picking up detritus where they could find it. They weren't eating each other.
They weren't eating each other. Down here in the water, everybody's just chill. Everybody's vegan. It's the most peaceful time on Earth.
I'm a vegetarian, and I look kind of fondly back at that long ago time.
Imagine a life. No fear, no anxiety. You just swim around and you graze a bit here, you graze a bit there, and everything is good. And I'll tell you what else is really good. The water is really good for coffee. Back on land, we drill a hole into the rock, pull up some groundwater, and brew up a coffee. And the first reason this is really great water for coffee is our kettle. It's not getting gunked up with limescale. It still looks shiny and new. And what else makes it really great water for coffee is the flavor. I take a sip. And the coffee tastes really vibrant. Like, there's a really nice acidity there. And of course, we as specialty, we love acidity in our coffees. Now, the reason this is great water for coffee is because what we have in the water are like the Goldilocks amount of two specific minerals, calcium and hydrogen carbonate. Let's start with hydrogen carbonate. So us here in specialty coffee, we love acidic coffees. And lighter roasted coffees are full of natural acids. And when we brew coffee, we pull those acids into the water. But floating around in the water can be hydrogen carbonate. And as Samer Smurkay of the Coffee Excellence Center explained to me, hydrogen carbonate
will neutralize the acids in our coffee. So it will lower the acidity of the brew.
So hydrogen carbonate is the thing that kills acidity. And we don't want that because we like acidic coffees. And what we want is a little bit of hydrogen carbonate. Not too much, not too little. Let me show you why. So let's imagine we brew a coffee where the water has 0 hydrogen carbonate in it. As we're brewing the coffee, we extract acids into the water from the coffee powder, and those acids taste really sharp. They're a bit overwhelming, a bit puckering. But if the water has just like a little bit of hydrogen carbonate, the same amount as this ancient water has, then it just takes off the intensity of that acidity. And so what we get left with is like a really nice sparkling coffee. But if you have too much hydrogen carbonate in the water, like I have in my tap here in Berlin today, then there's lots and lots of hydrogen carbonate going around neutralizing all the acids. And so that sparkling acidity just becomes dull, lifeless. The flavor's muted. So when it comes to hydrogen carbonate, you want the Goldilocks amount. Not too much, not too little. Just the right amount, like this ancient water has. And so the coffees sparkle with a nice acidity. So that's the flavor side. But the other thing this ancient water has in the perfect amount is calcium. Now, we want a little bit of calcium in our water because if we didn't have any calcium in our water, chances are when the water is being boiled in our espresso machine boilers, in our kettles, it will corrode the metal because water can be slightly acidic. But what happens is that if you have a little bit of calcium, that calcium reacts with the hydrogen carbonate we just saw earlier, and it forms this protective film of limescale, coating the metal, protecting it from the acidic water. But if you have too much calcium in the water, then what you get is a buildup of limescale. Layer upon layer upon layer. Our espresso machine boilers and kettles get gunked up. But 550 million years ago was this paradise moment in the history of the world where the water was great for coffee because it had just the right amount of hydrogen carbonate and calcium to keep our coffees nicely acidic and the metal of our boilers protected but not gunked up. And on top of all of that, life on Earth was living in this vegetarian paradise. Critters swimming around with no protective armor, no shells, because no one's going to eat them. And so to keep this groundwater perfect for brewing coffee, all that has to happen is that the hydrogen carbonate and the calcium that's over there in the ocean stays there. If the hydrogen carbonate and the calcium that's floating around in the water just stays in the water, we today would have perfect water for coffee out of our taps everywhere. But something is going to happen to ruin our water for coffee. Something that's going to transfer literal mountains of calcium and hydrogen carbonate from the ocean over there into the rocks under our feet.
And over time, huge volumes have changed hands.
And it is that transfer of all the hydrogen carbonate and calcium in the water onto land that eventually is going to gunk up our kettles and neutralize the acidity in our coffees, making them taste lame. And the culprit, the thing that transfers all this stuff from the oceans to the land, are those little critters swimming around. That story coming up next. So, 550 million years ago, we had great water for coffee. The groundwater had just enough, not too much, not too little, of calcium and hydrogen carbonate. Our coffees were tasting lovely, bright and acidic, and our kettles weren't getting gunked up with limescale. And to make things even better, we lived in a vegetarian paradise. And all we have to do to keep things this perfect is to ensure that all the calcium and hydrogen carbonate that's out there in the ocean, it stays there and does not make its way onto land. But as ever, somebody comes along to ruin the good times. What happens is that down there where all these little critters are swimming around, not eating each other, one day, one of them thinks to themselves, you know what? That critter over there looks pretty tasty. And voila. Predators. It's a bloodbath. These predators are going around eating all these defenseless critters. And the critters say, no, we will not let this stand. We must protect ourselves. We will create armor.
Shells become important because if you're soft, squishy, wormy kind of thing, you're going to get munched. So shells are just an evolutionary way of avoiding being eaten.
And these critters make their shells by taking two things that are floating around in the ocean.
The shell is made of both calcium and bicarbonate.
Hydrogen carbonate and calcium. The two things we don't want too much of in our water for coffee. And critters start making these shells in huge quantities for millions and millions of years. We have critters making these shells. And the problem with these shells is that the material they're made of, the fusing of hydrogen carbonate and calcium, it's known as calcite. And calcite, it doesn't decompose. It sticks around. And so all these shells made of hydrogen carbonate and calcium, they just accumulate and accumulate and accumulate. Millions, tens of millions of years of just accumulation. They become as big as mountains. 50 meters, 100 meters, 200 meters, a kilometer deep. But remember, this is all underwater. It still hasn't made its way onto land. Until it does. Because of plate tectonics. The plates move under another, and sea floors get pushed up above and becomes the land that we are standing on today. Under our feet are the remains of these critters' shells.
I live on dry land, but this area was once below sea level and a warm, shallow, tropical marine environment in which different calcifying organisms were living, dying, and essentially ending up in limestone.
Limestone is absolutely everywhere across the world, and it is the remains of the shells of these ancient critters.
The White Cliffs of Dover are the classic example. If you look at that white chalky limestone under even a pretty low magnification microscope, you see it's just fossil shells that have accumulated over time.
Peeps, you really have to see this for yourself. Look at the show notes. It is amazing. There's one that looks like a soccer ball made of discs. There's a critter that looks like a sea mine. There's one that's like a ball with like trumpets coming out of it. It is otherworldly. It is extraordinary. And to think, for so many of us, this is what the limestone is made of under our feet. And if you live in a place where the ground beneath you is made of limestone, you have bad water for coffee. Because your water is going to be full of calcium and hydrogen carbonate, the stuff that makes up this limestone. But how exactly does the stuff limestone is made of, calcium and hydrogen carbonate, how does that get transferred into our tap water? Okay, so what happens is that when it rains, water hits the ground and it seeps through the ground and makes its way in between the underground rocks. And if that rock is made of limestone, the water will dissolve it. And so the stuff limestone is made of, hydrogen carbonate and calcium, they are dissolved into the water. And like I mentioned, a little bit of these two things, it's good for coffee. But if you have too much of it, it's bad. It kills our acidity and gunks up our kettles. But I got to say, there's something really kind of cool about limescale forming in our kettles and espresso machine boilers. Because what we're kind of doing is summoning the spirits of those ancient dead critters. When I was at the offices of BWT in Wiesbaden, they were doing a test where they were boiling super hard water in a transparent kettle. And I could see for myself limescale forming before my very eyes.
Well, yes, the first one here, the very hard one, you can see it's almost white and milky.
Wow, yeah, look at that. So on the bottom of this kettle, one boiling, you can already see there's like a very, very fine silt. Exactly. Wow, that's wild, from one boiling session. That fine white silt I was seeing on the bottom of the kettle, that is limescale. My kettle here in Berlin is full of it. Yours might be too. But the thing is, that gunky limescale, that is the reconstituted shells of those ancient dead critters. Those critters, hundreds of millions of years ago, they took calcium and hydrogen carbonate and made protective shells. And then you fast forward hundreds of millions of years to today, and our water is full of their dissolved shells. And when we boil our kettles, they reform again. It's the same substance that these ancient critters used to protect themselves. It's like every time we put on the kettle, we are calling the spirits of these ancient critters, connecting our souls with the souls of critters who lived 500 million years ago. And I am absolutely pissed off. How dare they? How dare they ruin my coffee like this? I want to be able to open my tap and not have their ancient shells ruin my coffee. It's because of their ancient shells that my coffees taste lame, that my kettle's all gunked up. Wouldn't it be better if they just had never done it in the first place? But our geologist, Marsha, she disagrees with me.
And I'm grateful that calcite exists.
She's happy that those ancient critters made their protective shells because it was the act of creating those shells that prevented the apocalypse.
If we didn't have limestones, we would be a runaway greenhouse planet like Venus. So I know you're concerned with the coffee story, but from an earthling perspective, limestone is hugely important because it sequesters not only calcium, it sequesters carbon dioxide.
So when volcanoes erupt, they release huge amounts of carbon dioxide, CO2, into the air. And too much CO2 in the atmosphere, that's a problem. It's the reason we have global warming today. But the surprising thing is that a lot of the CO2 from those ancient volcanoes is no longer in the air and has been locked away deep underground into limestone.
99% of all the CO2, carbon dioxide, that's ever been exhaled by volcanoes is stored in limestone.
Because those ancient critters, to build their shells, what they would do is take the CO2 that had dissolved into the ocean, which then reacted to form this thing called hydrogen carbonate. The same stuff we've been talking about throughout the episode. Hydrogen carbonate in the water comes from CO2. And of course, those little critters, they would take that hydrogen carbonate, mix it with calcium, and boom, protective shell. And so, these ancient critters forming shells is what locked away CO2 into the limestone rocks under our feet, keeping the CO2 out of the air. These little critters making their shells saved our dear planet Earth from runaway global warming.
If we did not have that mechanism that is largely by little shelly critters living and dying and sequestering away this mineral, all that CO2 would still be in the atmosphere and we would be this hellish greenhouse planet.
And so, our tap water, which for so many of us is bad water for coffee, it's the price we specialty coffee lovers have to pay to even be alive and enjoying coffee in the first place. As ever, Masha put it beautifully.
So even though it's a bit of a bother, I think we should say a little word of thanks for all the calcifying organisms that are sequestering all that calcium and that CO2 for us.
All right. I'm sorry, little critters. I'm happy you made your shells. You screwed up my coffee, but I'll tolerate it because it's a small price to pay for even being able to enjoy coffee in the first place. So, I hope that little story cements for you two things that really matter when it comes to good water for coffee. The amount of hydrogen carbonate and calcium. Like I said, you need some, but not too much. But how much exactly? Coming up in the next episode, I take you into the story of how the specialty coffee community figured out what is good water for coffee. Because in this episode, we've been focusing on just calcium and hydrogen carbonate, two super, super important things, but it's not the whole story. There's more in our water that matters for good water for coffee. And in the next episode, I take you into that story of how the specialty coffee community figured it out. And as ever, if you enjoyed this episode, please share it with your friends, take a screen grab, share it as a story on Instagram, and tag me at Filter Stories Podcast, so I'm able to thank you personally. This episode was made by me, James Harper. I also write and play the piano music. I hope you enjoyed it, and I can't wait to speak with you next time.